For an algebraic proof, we're going to use the top part of the cheat sheet with all these algebra reasons that you knew. You probably won't even need your cheat sheet for these because you know them in your head already, but they are up there if you need them. All right, so the first thing in a proof, by the way, a proof is a logical argument where the statements are on the left and why you're doing it is on the right, and it's going to allow you to reason from the beginning of the problem onto how you get your solutions. Some of your Algebra 1 teachers might have had you do this when you did your problems. They might have made you justify your steps. So that's what a proof is justifying your steps. So you have this problem here, and we're trying to solve for x. So the first thing we would do is add 8. Now, when you write it in a proof, you don't actually show the plus 8. You just write the result. So if I added 8, I would have 5x plus 1 on top, 2 on bottom, equals 8. That would be the result of what I get by adding 8 to both sides. So what do I call that? Well, what allows me to do that is the addition property. And that's because I did it to both sides. So I'm going to call this addition prop. I added something to both sides of an equation. Next, I'm still trying to get x alone, so I need to move that 2 because I can't touch the top until I get the denominator off. So I'm going to times both sides by 2, and I just write my result. So if I times both sides by 2, I actually don't times the 5x plus 1 by 2 because I'm just moving the 2. So I would get 5x plus 1 equals 16. That is called the multiplication property. It's an algebra property that you know from Algebra 1. Next, I'm going to move my 1. So to move my 1, I subtract 1. So I write the result once I subtract 1. I get 5x equals 15. That is called the subtraction prop. If you write sub, I won't know if you mean substitution or subtraction, so make sure you put enough letters that I know it's subtraction. And then finally, to get from step 4 to 5, I would need to divide both sides by 5, and that is an algebra property that you've learned called the division property. So that is what an algebraic proof looks like, and that should feel pretty good to you. Now we're going to take that idea and skip to number 16. And you will go back and do the other ones eventually once we get done. But I'm going to demonstrate the first segment proof for you. All right. So again, the statements will be on the left and the reasons will be on the right. The first step is wonderful because it's given. Something has to be given to you. So the given is what is in the given, and we're allowed to just transfer that down. Sometimes it's already there for you, but in this case we have to write it. They gave you that wy was congruent to xz. So those two things were congruent to each other. Now we're going to use all of these reasons and figure out what we can say for the statements. Okay? So they would like us to apply the definition of congruence. So I go to my cheat sheet and I see what the definition of congruence says. Let's see. Oh, if something's equal, then it's congruent. Or if something's congruent, then it's equal. That's the definition of congruent. So now I'm going to apply that idea to my step. If my two segments are congruent, then I could take the bars off and say that wy equals xz. That is allowed because of the definition of congruence. That's the justification for it. Next, they'd like us to use the segment addition postulate. So I'm going to come over here to my cheat sheet and I'm going to look at number 11, and I'm going to look at how segment addition is set up. Oh yeah, remember this? It's the little piece plus the little piece equals the big piece. That's what segment addition is. So I'm going to take that idea and apply it to my picture. Okay? Wx plus xy will equal wy. And then I'm going to do it with xz. Now xz is the big one, so I'm going to have to break that up into the two small ones. So that would be the little xy plus the little yz. Next, step 4 is the hardest, so I'm going to star that. This is where kids start having a lot of trouble because they would like us to substitute. So we have to figure out how to substitute here. And so to do that, I need to go up into my proof and find something that I might be able to take out and replace that would match. So if you guys will circle these wy's and notice that those wy's match each other, right? So I'm going to take out this wy right here, and I'm going to replace it with all of this right there. So up here in step 2, I'm going to replace that with wx plus xy. And I'm allowed to do that because the wy's match. So I'm just bringing this up and putting it in its place. All right, and then on the other side, you might notice I'm going to have you put a box around the xz and a box around the xz. These xz's match. So I'm going to take out this xz and I'm going to replace it with everything that's on this side. So all of this equals xz, so that's going to go up here and replace this xz. So I'm going to go xy plus yz, and I'm going to put that in step 2. So take a second and look at what I did. I put this information in for the wy, and I put this information in for the xz. That is what I'm going to write in step 4, because I substituted something on both sides. It's like doing a double substitution. So my equation in number 4 would be the wx plus xy equals, and on the other side is xy plus yz. That is a really difficult thing for kids to get, so we just have to keep practicing it until you guys see that. Okay, next it would like us to use the subtraction property. This looks weird because it's geometry, but if you notice, do you see how these two things match on both sides? If you have an equation where you have things that match on both sides, you're allowed to subtract those off. So it's kind of like minus xy, and they're going to disappear. So we're going to be left with wx equals yz. That's all that's going to be left when we subtract those off. Now, they would like us to use the definition of congruence one more time, but the other way. And the reason is, look at what we're trying to prove. They wanted us to finish the proof with congruence, and right now we're at equals. So we're allowed to go back to congruent by adding the bars on and putting the little wave on, and change it back to congruent from equals. So kids ask me all the time, why would they ever do that? It's because the proof started with congruent and finished with congruent, but we used equals in between. So we had to switch to equals and then switch back to congruent at the end.